Eduport presents human physiology, excretory products and their elimination. Many nitrogen containing substances, ions, CO2, water, etc., that accumulate in the body have to be eliminated. Nature of nitrogenous wastes formed and their excretion vary among animals, mainly depending on the habitat, availability of water. Ammonia, urea, and uric acid are the major nitrogenous wastes excreted. Protonephridia, nephridia, Malpighian tubules, antennal glands or green glands, and the kidneys are the common excretory organs in animals. They not only eliminate nitrogenous wastes but also helps in maintenance of ionic and acid-base balance of the body fluids. In humans, the excretory system consists of one pair of kidneys, a pair of ureters, a urinary bladder, and a urethra. Each kidney has over a million tubular structures called nephrons. Nephron is the functional unit of kidney and has two portions, that is, glomerulus and renal tubule. Glomerulus is a tuft of capillaries formed from afferent arteriole, fine branches of renal artery. The renal tubule starts with a double called Bowman's capsule and is further differentiated into PCT, proximal convoluted tubule, Henle loop HL, and distal convoluted tubule DCT. The DCTs of many nephrons join to common collecting duct, many of which ultimately open into the renal pelvis through the medullary pyramids. The Bowman's capsule encloses the glomerulus to form Malpighian or renal corpuscles. Urine formation involves three main processes, that is, filtration, reabsorption, and secretion. That is, filtration, reabsorption, and secretion. Filtration is non-selective process performed by glomerulus using the glomerular capillary blood pressure. About 1200 ml of blood is filtered by the glomerulus per minute to form 125 ml of the filtrate in Bowman's capsule per minute GFR. JG cells also helps in this. JGA is a specialized portion of the nephrons plays a significant role in the regulation of GFR. Nearly 99% of reabsorption of the filtrate takes place through different parts of the nephrons. PCT is the major site of reabsorption and selective secretion. HL, Henle loop, primarily helps to maintain osmolar gradient, that is 300 milliosmoles per liter to 1200 milliosmoles per liter within the kidney interstitium. DCT and collecting duct allow extensive reabsorption of water and certain electrolytes, which help in osmoregulation. H plus ions, potassium ions, and ammonia are also secreted into the filtrate by the tubules to maintain the ionic balance and pH of body fluids. A countercurrent mechanism operates between the two loops of Henle and those of vasa recta, capillary parallel to Henle's loop. The filtrate gets concentrated as it moves down the descending limb, but is diluted by ascending limb. Electrolytes and urea are retained in the interstitium by this arrangement. DCT and collecting duct concentrate the filtrate about 4 times, that is, from 300 milliosmoles per liter to 1200 milliosmoles per liter. DCT and collecting duct, an excellent mechanism of conservation of water, is the example given above. That is, DCT and collecting duct concentrate the filtrate about 4 times. Very important. Urine is stored in the urinary bladder till a voluntary signal from the CNS carried out its release through urethra, that is micturition. Skin, lungs, and liver also assist in excretion.